Assalamu alaikum wa rahmatullah. Welcome to our third experiment in this semester. Our objective is to determine the parameters of the single-phase equivalent circuit of a three-phase transformer. To do so, two tests should be performed. Open circuit test, which would lead us to find the parameters of the core, and the short circuit test to find the parameters of the copper of the primary winding and the secondary winding. So both tests will be performed at the secondary side, which is the low voltage side of the transformer. So this figure here shows the equivalent circuit of the single-phase equivalent circuit of a three-phase transformer, where we have a representation of the core part and the winding or the copper. We'll have losses. This represents the losses in the windings. So the open test, the equivalent circuit will be simplified to this figure here, where in open test the current will be 0. So the drop across those impedances here will be 0, and so that we can end up with this figure here. We'll have only the core representation, parameters of the core. So by doing the test, the open test, some parameters will be found, such as the power. So power at open circuit will be measured, and from that power we can calculate. If we know the power, we can calculate the power factor cosine theta at open circuit. Okay, knowing that the power which is square root of 3. Okay, and the V open circuit, but here line to line. Keep in mind that we are working in three-phase, not in single phase, but a presentation it's of the equivalent circuit, it looks like single phase. So root of 3 times V open circuit line to line, and multiply by the current at open circuit, which is the current here, open circuit, cosine theta at open circuit. This is general form of the power of the active power. So cosine will be from here, the cosine theta at open circuit will be equal the measured power, active power at open circuit, divided by root of 3 times V line to line at open circuit, of course, which is here. What you have, we have line to neutral. This is single phase representation. Okay, so the wattmeter will be used in this experiment will show us both parameters, both quantities, which is line to line and line to neutral. So we select line to neutral, line to line, sorry, and times the current, at the open circuit. Okay, so this parameter here will be measured in our test. This will be measured also, and this one also will be measured. So we can use this formula to calculate the power factor. The power factor is needed to find the parameters of the core in terms of I mean by this the resistor, and then this inductance or reactance here for this the core. Okay, applying Ohm's law, which is V equals R I. For our case here, okay, V line to neutral, okay, across this, if we start with the resistor, will be equal R okay, core, okay, here C for a core times the current circulating in that resistor, so which is IC. Okay, that's the IC here, I for the core. Okay, now, but this IC will not be measured. Okay, the measured one is I open circuit. So phasor form of I open circuit will be having this representation. So that this is IC in the core, and that's circulating the resistor, and in the inductance will be perpendicular to this vector here. So this is I. Let's say M for magnetization, M, which is that one here. This is IM. Okay, the resultant of that, the sum, the victorious sum, will be given I open circuit. So this quantity is measured, this I open circuit, and that's the theta here. Sorry. That's the theta open circuit. So so now I open circuit, okay, times cosine theta open circuit will give us this or equals IC, I core. So now we can replace this I core here by this formula. So V line to line, line neutral, sorry, will be equal RC times I open circuit cosine theta open circuit. Okay. So as I told you at the beginning, this V line neutral can be measured by the wattmeter, or if we measure V line to line, we take that V line to line measure divided by root of 3, will give us the quantity of this V line to neutral. So RC, okay, this is our first parameter of our equivalent circuit, will be equal V line to neutral, okay, open circuit of course, divided by I open circuit, the measured quantity, the current at the primary side, cosine theta open circuit, which is calculated. So this one, it will be measured. This quantity is measured also, and this parameter is calculated. Okay, now RC found. Let's find XC or XM. So XM will be equal, same thing, the V line to neutral open circuit, which is the quantity of here of this voltage across these two elements. They are in parallel. So across those two elements, we have the same voltage, which is V line to neutral, divided by the current here, which is IM, and IM function of IOC will be IOC, which is I open circuit, times sine theta here, which is this quantity IM. So I open circuit sine theta open circuit. So you can find the cosine inverse of cosine inverse will give us theta, and sine theta. So theta will be known, and you can calculate its sine quantity. So those are the two parameters we're looking for. Okay, for the core. So now for the short circuit test, where we short the low level side, the secondary side will be short circuited, and there we're going to apply a small voltage at the input, we supply our winding, the primary winding, by a small quantity of voltage. So that small quantity, because it's very small, the core losses will be neglected, and the input power will be taken by entirely by the copper losses in the windings. So the equivalent circuit will be the one seen here. Okay, we'll end up with the equivalent impedance where we have R1 and R2 seen from the primary, and X1, X2 seen from the primary side. So this is the equivalent circuit of the short circuit test. Okay, the voltage is small as we told, so the losses here will be very small, so we can neglect them. That's why we don't show that part here of this core, the core parameters. Now, from this short circuit test, this multimeter will show us. So this is another part here. I'm going to write in this side. Okay, power at the short circuit. This is the active power, and we're going to measure also I short circuit. Sorry. Okay, and R equivalent. Okay, this keep in mind this is active power, so will be dissipated across the resistor. So R equivalent will be equal the power divided by I squared. Okay, but keep in mind we have the power here, the measured one will be for three phase, so divided by 3. This power will be divided by 3 and multiply here by I short circuit squared. Okay. Okay, this is found. Now we can find Z equivalent in order to find X from this Z equivalent. So Z equivalent, which is this impedance, that's Z equivalent, and the voltage across this the Z equivalent will be V line to neutral at short circuit. So this will be a measured quantity. So V line to neutral for short circuit test, okay, divided by the current going or flowing in that circuit, which is I short circuit. So those two parameters, they are measured parameters given by this power meter. So Z would be calculated. Once Z is calculated, we can find X equivalent, which is root of Z equivalent, the calculated one, squared, minus R equivalent squared. So now we found our three parameters, the R equivalent, and we found only two parameters here, but we went through Z equivalent to find the second one. So this is R equivalent and X equivalent for this circuit here at short circuit test. Okay, so now those parameters are found. If we go to the next page, where I'm going to explain practically what you have to do. So what we can see right now here in front of us is the short open circuit and short circuit test for three-phase transformer. Okay, here we supply our three-phase transformer by three-phase supply. Okay, so we have our transformer primary side. okay, and secondary side, and we connect them Y connection. Okay. The circuit shown here, this diagram shown here, it shows two method wattmeter. So we have 2 watt meter, 1 watt meter here, and the other one here. Okay, we can add the displayed power, and this will give us the total will give us the total power. Okay, at the input of this transformer, and we measure the current using ammeter and another ammeter here. So 2 voltmeters and two ammeters to measure the current flowing in the first winding and the voltage across the two windings. This will display V line to line, and this is the current line. Okay, so in this line. In the low level side, low voltage side, okay, for both configuration, in open circuit, we can just leave it open. Okay, this this secondary part, or we can just connect a voltmeter like between two lines, just to measure the V the secondary side. The short circuit side, we can make short circuit using a meter. Okay, and a short circuit making wire in the other side, the other part of or the rest of this secondary side. Practically, we have, instead of using 2 watt meters, we have one electronic power meter where we can supply directly or connect directly to our three phases, line 1, line 2, and line 3. That's the supply. And this is the power meter. Okay, here we have a certain display where we can display the power, either active, reactive, and apparent power. The voltages V line to line, V1, V12, V13, and so on, and the current also, the current in the circuit. So this is what we call connection line, one-to-one, the direct connections. Okay, I'm going to do something like this, like this, like this. So we need 3 wires. The first one here, the second one, the third one, connecting the power supply to our power meter, and as input. So in 1, in 2, in 3, and so on. The output will be connected one by one directly to our primary transformer. The secondary will be kept open, okay, like this. That's the core. For the short circuit test, so we can just make a short circuit, like 2 wires to connect, to make short circuit between those terminals and the secondary side. Okay. So for the open circuit test, we apply rated voltage. Okay, so rated voltage, it's measured by the transformer, and in the short circuit test, we apply a small voltage at the primary side. Okay, and we keep our eye at the current, which should be rated current. rated current like this. Okay, so once we perform the open circuit test, be sure before you go to the short circuit test that the auto transformer, because we're going to use auto transformer at the primary, the line side, okay, just to adjust our input voltage. So be sure that from this test to this test here, we bring back the knob, okay, to zero position, 0 volt. Otherwise, we're going to burn the transformer. Since once we perform open circuit test, we have to apply rated voltage, and usually rated voltage is around 220 volts. So if we keep this one, we forget to bring back this knob, or reduce this voltage to zero, from 220 to zero, and we apply short circuit, and we open the breaker. We make it on. We're going to reach a very high current, short circuit current, and this will be greater than the rated current here, and we can damage the auto transformer. So now, practically, I took a picture or photos of our stations, so I can do connections directly here, or do the wiring here using my pen. So I can show you exactly how we can connect our circuit. Uh, Keep in mind that we have two different stations in our electric machines lab. The one we call feedback, which is the white one here, and the other one we have 4 feedback, and we have 2 normal stations, the black ones. And I'm going to show both of them. One more thing before we continue. Remember that we can build our transformer, our 3-phase transformer, using 3 single-phase transformers, and this will be done in the other 2 stations, not in feedback station. In feedback station, we have directly, our 3-phase transformer, the one we can see in front of us. So here, before we supply anything, we have to connect our primary and secondary. We make them Y and Y connection, both sides. As you can see, we have separate windings with different ratings. We'll use this part here for our test, so 230 instead of 400. This is our primary. Okay, this part here. We'll take both side, the last sides or terminals of each one of them, and you connect them together. So by doing so, I'm doing my Y connection. So one wire coming here, the other wire will be connecting this terminal to the other one. So these those 2 wires, okay, they create what you call Y connection. Okay, that's the center point that connects the three windings, and you can form a Y connection. Same thing will be done from at the secondary side. Keep in mind we'll use only one side because the ratio wanted for our experiment is 2 to 1. So 230 to 115. This is 2 to 1 ratio of our transformer. So we'll use the secondary, the second part here, or the first, the one the top here. So either this or the one in the bottom side. Let's take the bottom side since it's clear for us here, and we do same thing. We connect with 2 wires, those terminals, and by doing so we can have Y in the primary and Y connection in the secondary side. Okay, now if I scroll down here, scroll up, sorry, and going down. So here we have, if you remember in our previous experiment, we have our 3-phase supply. That's the variable 3-phase supply with the variable DC supply here. and the fixed DC supply and fixed DC supply. Since we have to adjust our voltage from 0 to a nominal value, the nominal value of the voltage applied to our transformer, we're going to use the variable three phase. And those line by line, they are fused. So we have a fuses 4 amps here. Of course, we cannot exceed 4. If we exceed 4 amps, those fuses will cut and will be burned, and they open the circuit. Okay, so now if I do like this, let's change the color maybe of our pen. So let's take maybe blue one. Okay. So now, as I told you, we have to connect our lines directly to the primary. But since we need to measure the power and the voltage across each winding, and the current flowing in that transformer will be going through that transformer, that power meter, the one you can see next to our transformer. Okay, so this wattmeter here will be it has like inputs, so line to line directly, 1 to 1 and 2 to 2 and so on. So we'll go from line, that's the supply. So from here a wire will be connected to this terminal. So we're applying or supplying this part from line 1, same thing from line 2, and line 3, the third phase, will be connected to this terminal. Okay, so those are the first connections to be done. The second connection, sorry, after making our Y and Y connection here, so the second connection is to connect our supply to that power meter. So this the power meter now will give those line, will connect those lines, okay, from here to the first line, and the yellow one to yellow, and so on, and the blue to blue, or line 1 to line 2, line 2, so line 1 to line 1 to A1 here, line 2 to B2, and line 3 to C2. Okay, I'm going to do something like this. So right now we're supplying our primary side from this three-phase supply, but through our ammeter, through our watt meter. Okay, as I told you, we're going to keep the terminals here of the secondary part open, so no connections to be done there. So those are the three connections. The first one for Y and Y connection. The second connection is to connect our supply to our watt meter, and from watt meter to our transformer. The display here, okay, the display here will show. Let's change the color also one more time. Let's go back to red. Okay, so this will display voltage, so V, that you here, which is voltage, will display frequency of your supply, will display the current for each line. The voltage here will be line to line, and the line to neutral displayed in this screen here. The three type of powers, so the active power, the reactive power, and the apparent power will be displayed. So each time, if you have like two parameters in one button, to switch from one to the other one, you have to click on that button. You click on it, so you can keep clicking and For this example, if you keep clicking one time, the active power will appear in this window. Appear another click, the active reactive power will be displayed. Okay, and Q, and another click, the S power, the appearance power will be displayed. This button here to show our power factor. Okay, this is for the energy, and this for time. Okay, the ones will be used in our lab will be those 4 parameters here, 4 buttons. Keep in mind we have to calculate power factor, but let's display it here and calculate it at the same time, and try to compare your power factors. So this is for feedback and three-phase transformer tests open and short circuit. Open circuit for three-phase transformer in feedback station. For once it's done, you recorded all values, for example. So keep in mind, please, that you have to move back this knob here. Now with my mouse. Okay, this knob should be turned back to 0. Okay, and switch off your power. So this is towards 0 volt, this position like that. After that, you make a short circuit, okay, in the secondary side. So those windings, they are separated, and we can connect them through wires here, 2 wires. By doing this, we are doing our short circuit test. Okay, now we turn on our circuit breaker. Emergency stop to be on position to permit this circuit breaker to switch from off position to on position. And after that, we have to second thing to be done is to display a current here, so that as soon as we can or while we are turning this knob here toward a certain value of the voltage, we can check the current, and the current should not exceed the rated power, the rated current for that transformer. So we're going to show you how we can do this, how we can find the rated current of this transformer. So same thing for that test. Once we reach the rated current, we stop turning this knob, okay, the voltage knob here, the variable voltage, and we can record the voltage and the frequency, if you like, the voltage, the current, the powers, and the power factor for short circuit test. That's for a feedback station. Okay, going back to our other station, other type of station, we're going to use the same wattmeter. We have 3 single-phase transformers, and we have our supply, three-phase supply. So same thing, we can use a fixed three-phase supply. So that's a fixed one, okay. And variable power supply, if we need the variable three-phase power supply, so we take those fixed power supply and we to this input here for this auto transformer, and here we go with output variable AC three-phase supply in this side here. So the first thing to do is to join those terminals by wires. Okay, so to make our input variable, we have to connect this terminal to this terminal and so on through user wires. So this is now our variable that was a fixed supply, and this is a variable supply now, this side. So variable supply, we will connect, will supply our three-phase transformer through a wattmeter. So same thing, yellow with yellow, blue with blue, and red with the red connector. Okay, and now before to go to the other side, I will connect the other, our transformer. We'll take this rated voltage here. So we'll take the whole winding for this single phase transformer, and this form our Y to Y connection, Y in the primary. So this primary with this primary of this transformer, this primary with this primary side of the last transformer. Okay, same thing we have to do for secondary side. Let's change the color for more clarity. I'm going to take let's take this yellow here. Okay, same thing for the secondary. The secondary side will take secondary with secondary, and secondary with the secondary of the other transformer. So by doing this, we end up with the three-phase transformer with the Y connection at the primary and Y connection at the secondary. Now coming back to our transformer, our wattmeter. So this line will be supplying the primary of this transformer. This line will be supplying this primary also of the second transformer, and this line number 3, the last one, will be supplying the primary of the third one here. Okay, and that's it. We end up with a similar connection of the last circuit. We're used in feedback, in feedback stations. Now, same thing. We display voltage for open circuit test, and open circuit test here, and we turn this knob toward nominal value of the voltage. Of a V. So once we display nominal value here, we stop and we start recording our voltage, current, the three power, the active power, reactive power, and the apparent power, and also the power factor. One more thing, we switch off after that by pressing this green button, which is off button. Okay, press this one and this will trip this circuit breaker, so no power going to that transformer. After that, we make short circuit. Okay, between this terminal and this terminal here, from this terminal to that terminal here. So this is a short circuit test. Now, before we make our circuit breaker on, we have to be sure that this one was returned to 0 position or 0 volt, and after that we activate the current, and we turn slowly this knob toward the rated current, okay, of the transformer. Once we reach that value, we stop and we record the whole other parameters, because they are needed to find out or calculate the parameters of the copper for this short circuit test. And once it's done, we can switch off our transformer and turn back this one to 0 position. So those are basically the tests to be done in this lab. Okay. Okay, so it's clear, it's straightforward. The connections, they are really clear and simple. And once it's done, you can through those from those recorded parameters or values, you can calculate your equivalent circuit of the single phase equivalent circuit of the transformer. Thank you.